All right, this is Unit 11, Day 7, Area of a Sector. I will do the warm-up right now. If you'd like to hit pause and try it on your own, you can. The owners of a new L-shaped office complex of a building have a shallow staircase up to the main doors shown in the diagram. The staircase is an area of a sector, is a sector of a circle with radius EF. Find the length around the lowest step represented by EG to the nearest foot. So they want this curved length right here, which is arc length, which is degree over 360 times the circumference. We don't want the whole circumference around the circle, only part of it. Now, the degree is right here. It is 90 out of 360 times pi. Now, let's figure out our diameter. Well, the whole circle, if you were to think about it, would go all the way around like that. So the radius would actually be right here. Well, that length is not 60 and it's not 28. Now 28 only goes to here. So whatever is left would be my radius. 60 minus 28 is 32. So the diameter would be 64. And I'm going to put that there. So we're going to be rounding to the nearest foot. So let's type all of this in our calculator. 90 over 360 times pi times 64. Enter and round. And it will be 50 feet. And that's a reasonable answer for the length of the staircase. All right. Today is called area of a sector. Area is the amount of the space inside a circle. So if I want to do the area of an entire circle, I would use pi r squared. A sector of a circle is a portion of the circle enclosed by two radii. So for example, only a little bit of the area. It is a portion of the area of a circle. So we're going to take that area formula and put a fraction in front of it. Degrees out of 360, so a part of the whole circle, times area. So we have circle O with a radius of 10. So if you want a picture of it, it would look like this. The area of the whole circle would be A equals pi r squared, pi times 10 squared, which would be 100 pi. Half the circle, so if we wanted only half of it, that's 180 degrees out of 360 times pi r squared. And you know what, I'm going to go back and just replace it with pi 10 squared. So this will give us 50 pi. If I only want a quarter of the circle, that's going to be 90 degrees out of 360 times pi 10 squared. And that's going to be 25 pi. And if I want a 60-degree angle, it's going to be 60 3/60ths times pi 10 squared. And this one doesn't come out super nice, so I type it in, and I'm actually going to math frac it, 50 thirds pi. All right. So we're going to continue kind of doing that. And again, you just need your degree and the radius for pi r squared when you're doing area. A circle with a diameter of 10 and a central angle of 30. What is the area to the nearest tenth of the sector formed by the 30-degree angle? So we want this sector right there. So it is area equals degree over 360 times pi r squared. The degree was 30 out of 360 times pi. Our radius, well, our diameter is 10, so our radius will be 5 squared. And we are rounding this to the nearest tenth, so we can go ahead and type all of it in our calculator. 30 over 360 times pi times 5 squared. Enter and round 6.5, and this is centimeters squared. And there is our answer for that one. All right. Why don't we go ahead and we'll skip number 3 and focus on some of the questions on the back. Number 4, the area of the sector of a circle with a radius measuring 15 centimeters is 75 pi. What is the measure of the central angle? Ooh, this one's a little different. The radius is 15 centimeters, and the area, they already gave this to you, is 75 pi. What is the angle? So this, we don't know. So we're going to use our area formula. Area equals degree over 360 times pi r squared. But we know the area. It's 75 pi. We don't know the angle, degree x over 360 times pi, and the radius was 15, so 15 squared. All right, how are we going to get that x in the middle of all that mess? I know the first thing I'm going to do, I'm going to cancel those pi's. Next, I'm going to try to get rid of the divide by 360. And if I want to get rid of something that's dividing, I'm going to multiply it. So times 360 over here and times 360 over here. Watch on the left, or sorry, on the right. Cancel, cancel. On the left, 360 times 75 is 27,000. And over here I have x and 15 squared, which I'm just going to type in my calculator. 15 squared is 225. And all I got to do now to get rid of the 225 is to divide both sides by 225. And that will give me my x, which is 120. And we were finding an angle, so that's actually degrees. And look how nice that turned out. All right, so we're each going to kind of keep throwing in a little twist on these questions, but we're always using that same formula when we're only dealing with a little portion of the area. Number 5, this picture looks interesting. We have circle O with a diameter and some radii. The length of AB is 12 and angle COD is 20 degrees. So it's kind of tucked in there. Arc AC and BD are equal. I'm going to put a little tick and tick on those arcs. Find the area of sector BOD in terms of pi. So they want this sector right here, which means we need to figure out area equals degree over 360 times pi r squared. I know the radius. If the diameter is 12, the radius is 6. But what I don't have is the angle of that section. Now, I know that the whole circle around is 360. I know halfway is 180. If this section's 20 and these two are the same, I think I can do 180 minus 20 is 160 and divide it by 2, and that would make each of these 80. So the section that I want in blue, the degree is 80 out of 360 times pi, or the radius is 6, squared. Now, how do they want us to round? It says in terms of pi. So I'm only going to type in 80 over 360, and I'm only going to type in times 6 squared. So when I do that, it actually comes out nice, 8 pi. And there's my answer. All right, number 6. Using the diagram, find the length of arc PQR. So they only want this length right here. Arc length formula is degree out of 360 times, what do we use for length? Circumference, so pi d. Now, is 162 the angle for that length? No, it is not. The length goes with this angle. So I actually have to do 360 minus 162, and that gives me 198. So I have to use 198 out of 360 times pi, and our diameter will be 30. And again, it does not say where we're going to round, so we'll leave it in terms of pi. 198 over 360 times 30, we get 16.5 pi. And this is just length, so it is centimeters. Now for area of the sector, we do degree over 360 times our area formula, pi r squared. So we're going to use that 198 again. But our radius is 15 squared. So 198 over 360 times 15 squared. I get 123.75 pi. And this will be centimeters squared. All right. Let's try one last question, and it's a little bit of a challenge at the end here. In the diagram, circle O, the area of the shaded sector is 2 pi, so they already gave us the area. The length of NL is 6, so this whole thing here is 6, and they want angle N. Now that is not a central angle, so we have to be real careful with that. Well, since they gave us area, I'm going to start with area, which is degree over 360 times our area formula, pi r squared. Now remember that this degree has to do with this angle. These are central angle values. So this angle is currently missing, so that would go there. Now, what do we know? The area is 2 pi. Pi over here, and our radius is 3 squared. All right, we did one up top like this. Cancel our pi's. Let's times by 360. We get 720 equals x, and 3 squared is 9. Divide by 9, and that is 80 equals x. But wait, that's not our answer. If this is 80, we know that this would be 80 degrees, but that would make our inscribed angle 40 degrees. So angle N is 40 degrees. Wow, what a challenging question. We had to use area, central angle, inscribed angle. All right, that is all for today.